So what actually happens to a country's power grid when the world starts getting hotter and hotter? Well, today we're going to dive into a really fascinating climate investigation that takes us all the way to the Pacific island nation of Vanuatu to find out.
We're going to zoom in on one island in particular, Efate. For the people living here, this isn't some abstract concept. The future of their energy is directly tied to the very real challenge of surviving a warming planet.
All right, so at the heart of this whole story is Efate's electricity system. There's one main company, Unelco, and they're the ones keeping the lights on for about 16,000 customers. We're talking everything from homes to hospitals. But that lifeline, it's under some serious pressure.
And if you look at how they're generating that power, you start to see why. This is their energy mix from 2022. And wow, that big number just jumps right out at you. A full 92% of their electricity comes from imported diesel fuel. Think about that. It makes their whole system really vulnerable.
So as researchers started digging into all this power data, they spotted something that turned out to be the first big clue, connecting the weather directly to the strain on their grid.
Okay, take a look at this chart. Each of those lines is a different year, from 2019 to 2022. But you can see they all have the same basic shape, right? Demand for power shoots up in the first few months of the year, which just happens to be Vanuatu's hottest season, and then it drops down in the cooler months. It's like clockwork, every single year.
Which, of course, leads to the big question. What is going on in those hot months? Why is everyone suddenly using so much more electricity? And here it is. This chart is pretty much the smoking gun. Along the bottom, you've got the daily maximum temperature, and up the side, you've got the hourly demand for electricity. You can see it clear as day. The hotter it gets, the more power people use. And the main reason for that, you guessed it, air conditioning.
And get this, when the heat gets really extreme, like during a heat wave, that connection gets even stronger. In fact, during those heat waves, the daily temperature alone can explain about 40% of the changes in electricity use. The hotter it is, the more desperate people are for a little relief.
Now, this link between heat and power isn't exactly new. But to really get why it's becoming such an urgent problem, we have to zoom out a bit and look at the bigger picture, the long-term climate trend that's been quietly turning up the temperature for decades.
This graph is really telling. It tracks the temperature of the single hottest day of the year, every year, all the way back to 1950. And yeah, it bounces around a bit from year to year, but that trend is just impossible to ignore. That solid black line, that's Efate, and it's on a steady climb. The main thing driving this energy demand, extreme heat, it's been getting worse for over 70 years.
Okay, so that's where we've been and where we are now. But what about the future? What happens next? This is where climate science can give us a glimpse of what Vanuatu might be facing down the road.
Scientists use these incredibly complex climate models to try and predict what's coming. And pretty much across the board, these models are all saying the same thing. Temperatures in Vanuatu are going to rise a lot. We're talking about hotter average days, hotter nights, and even hotter record-breaking heat waves continuing through 2050, 2070, and beyond.
Of course, how much it warms up isn't set in stone. It really depends on what the world does about emissions. You can think of it as two main paths. A best-case scenario, where we get emissions under control, and a worst-case scenario, where we don't. And that choice makes a huge difference.
Now, let's tie that back to the power grid. This chart shows what could happen to electricity demand by the year 2050. See those blue lines at the bottom? That's the best-case world, with lower emissions. But those orange lines at the top, that's the worst-case high-emissions world. The impact on the power grid is just dramatically different.
Let's just pull out one number to make this super clear. In that more warming future, the average hourly demand for electricity is projected to go up by 6.6% by 2050. And it doesn't stop there. If we look out to 2070, that number could hit 11%. That is a massive, massive extra strain to put on an already vulnerable system.
So when you see a forecast like that, it's easy to feel a little hopeless. But the whole point of this kind of research isn't just to predict a problem, it's to help find solutions. So how can Vanuatu get ready and build a more resilient energy future?
Well, there are a lot of really practical strategies on the table. Things like passive cooling, which is just a fancy way of saying smarter building design with better shade and airflow. Or urban greening, more parks and green roofs to literally cool down the cities. And of course, making buildings more efficient and ramping up renewables like wind and solar.
And here's one of the most powerful takeaways from the whole study. It turns out it's actually more effective to just build better, more insulated houses in the first place than it is to try and make our air conditioners more efficient. It's a great reminder that sometimes the solution is about smart, fundamental design, not just fancier technology.
In the end, what's happening in Vanuatu is really a powerful lesson for all of us. It shows just how deeply our climate, our energy, and our daily lives are all connected. The challenge is huge, no doubt about it. But by blending modern science with smart planning, a hotter future doesn't have to mean a powerless one. It kind of makes you think, right? What lessons can your own community learn from this?